All right, we are looking at IP16. This is one of our exponential growth or decay model questions. We're told that the population of Austin is about 494,000. That was the beginning of last decade. And then we're told that it increases 3% each year. They want us to write an exponential growth model. So our exponential growth model are going to follow this structure. It's going to be y equals a times 1. And I'm going to put plus or minus in there to the t. Because it's depending on whether you have growth or decay, you're going to use this. Now it says growth model in the problem, but this is really what should clue you into the fact that you want to use a plus. So we're going to use the plus model. Then what we really have to figure out is our A value, our starting value. So they give us that in the form of the actual population of Austin. The population of Austin is 494,000. It's the beginning of last decade. It's when this study begins or when it initiates. It's the starting value. It's the initial value. Then we have to give this R value. Now the R is a percent growth. So it's 3%. Okay. So we have a couple things that we have to do. Mainly what we have to do is focus on this 3%. Okay, 3% literally means 3 per 100, right? The word itself is telling you to divide by 100, per 100. We can't put it in with the percent symbol. It has to be in decimal form. So we are dividing by 100, percent, divide by 100, per 100. That becomes 0.03. I kind of had it there quickly, but it is 0.03, not 0.3. That's 30%. Okay, so now once we know that, we got our A, 494,000, we got our R, 0.03, and we can plug everything in. 494,000, 1, now it's plus 0.03, raise that to the t. Now technically it is the growth model, but typically we will actually add those up to get a single value there as our multiplier, our grow factor. 1.03, raise that to the t. That is the exponential growth model. So that is the first thing that they're asking for. What is the exponential growth model that will model the population over time of Austin, beginning with this population growing 3% each year? Okay. So now that we have that, they want to know, okay, well, what's the new population going to be when t equals 10? So we're just going to plug 10 in for t. We're going to do y equals 494, 1.03, and we're going to raise that to the 10th power. And at this point, you have to use the calculator. I'm trying to put it where we have the least amount of glare. Maybe there-ish. 494, 123 times 1.03, raise that to the 10. So I am plugging this thing in just like I'm seeing it here. Yeah, 494 parentheses. Ooh, look at that. I got a little typo there. Let me fix that. 1.03. Raise that to the 10th power. So do the caret button, 10th power. I'm going to hit enter. And that's going to be 663,894.6, round to the nearest person. So we're going to make that 4 a 5 because that digit there is a 6. So 663,895, let me write that down. 663,895, 663,895. This is the population of Austin 10 years later. We're tracking the population over time. So y is going to equal the population, t is going to equal the time. Now the last thing they asked us to do was to kind of estimate when the population hit a certain number. Let me write that down, 595,000. So we want to know, when did the population get here? When is population 595,000. Okay, so the only way to solve that right now is to kind of guess and check. I'm going to go ahead and fix this. This is kind of hard to read. You can actually solve this algebraically with logarithms, but we won't learn that for a while. We can get the t out of the variable and solve for t. And we plug this number in for y, because that's the y value. Basically, y is 595, and we want to know what is t. But we don't know how to get t out of a exponent yet, so we're going to have to guess and check. We know it's less than 10, because at 10 years we're at 663,895. We want to know when we got to 595. So really the only way to do this is just sort of play around with the numbers in the calculator. So I'm going to do, here, I'm going to clear this and bring up what I had before. But instead of 10 years, I'm going to go ahead and make that 9 years. At 9 years, I'm at about 644,000, still too high, so we'll try that again, and I'm going to make this 8 years later. Still too high. I guess I want to get down to 595. I'm over 600, so I'll just keep going down to 7. Only barely higher. I am just higher, and I'm at like 607,000, and I want to go to 595. So let's go to 6. Okay, now we don't hit it there, but we get to like 589,000. I want to get to 595, so it's going to be somewhere between year 6 and year 7. So sometime, as the population is growing, sometime between year 6 and 7, the population is going to hit 595,000. We can't get an exact number just yet, but wait for integrated 3. All right, so it's all about guessing and checking here. Again, here's your model, starting value, 3% increase, and 10 years later, this will be the population. Between 6 and 7 years, that's when we get the population up to here. Hope this is helpful. Message me anytime with questions.